good morning or good evening, everyone. Welcome to this webinar, which will primarily be discussing the WillowWood META flow foot, which is a new carbon composite unibody prosthetic foot with an active dorsiflexion ankle spring. I'll just ask everyone to mute, and it looks like everyone's muted. In terms of questions, if you can use the chat feature on Teams to pop your questions in the chat, and we'll address those at the end of the presentation. My name is Bill. I'm the Education Manager here at massonshealthcare. And Jairo Blumenthal from WillowWood. As you can see, Jairo is the Managing Director of International Markets at WillowWood. And he brings over 25 years of experience to WillowWood. Jairo has been a regular participant at our AOPA in recent years here in Australia, so you may have met Jairo for those that have attended AOPA conferences. And Jairo played a central role in the development and integration of the META family of feet to the market. So a few years ago, WillowWood acquired a company called MaxStride, which Jairo will elaborate on. And that essentially led to a partnership that led to the development of the META family feet, which is a unique unibody carbon, and now also some of the members of the META family are available as fiberglass feet. So Jairo will expand on that. Have a brief look at the META family. And there is the META Arc, which is quite a unique foot in the market that has an ankle that instantly adapts to terrain, which brings a lot of benefits to the amputee in terms of function and comfort. So I'll pass over to Jairo now to take us through the presentation. Thank you, Jairo.
Thank you, Bill. Thank you guys for joining us, and thank you for the opportunity to be talking to you again. It's always a pleasure. Thank you for Massons for allowing me to be here, guys. So in this next few minutes, I want to share with you a little bit of development of the META family and how it happened, and then focus specifically on the last child born, the last baby born, which is the META Flow, and we are really, really proud of it. So let me try to see if I can forward this to you. So just a quick overview. This is how the META family looks like until today, or right before the META Flow was officially launched. It's a family of 5 and now 6 feet. And I just want to explain and go over to you how we got here. So for many, many years, and for those who don't know, WillowWood is in business now for 117 years. It's 4 generations of the same family here in Columbus, Ohio, in the US. And a few years ago, a group of investors and former Oscar executives like myself, we identified the opportunity to transform and make WillowWood another powerhouse in the prosthetic industry, just like I think we participate and helped Oscar become, because when I started at Oscar back in '97, it was a company based out of mainly one liner. And from that one liner became a multiple family of liners and then feet, and the same opportunity we have here. So before our acquisition of WillowWood, WillowWood used to outsource the manufacturing of their feet with this company called MaxStride that you can see here on my screen. MaxStride is based out of Phoenix in Arizona. And interesting enough, MaxStride was specialized in manufacturing carbon fiber feet for other companies, private label, different companies, and they would manufacture those. So on our new strategy, when we at WillowWood, we decide to acquire MaxStride, the first decision we have to make is, okay, what should we do now with existing contracts that MaxStride has with our competitors? Should we keep those contracts? Should we break those contracts? And again, there is no right or wrong to this answer, but we as WillowWood, we decided to keep it. I think it's fair to follow the contracts. and also give us some sort of market intelligence to understand what's going on with other designs. But of course, we kept what we believe to be the best design for ourselves, and that's how the META family was officially born. From the META family, there's one thing in common with all the feet, which is this unibody design. If you guys could memorize or keep one word from this presentation, is this unibody design. And what does it mean? Every carbon fiber foot in the market is a combination of an upper blade and a lower blade. And every foot has a challenge, which is how those two blades will be connected, unified. The most common system is some sort of creating two holes and put two screws and two bolts connecting the two blades. The other option is to use some sort of wrapping, and we call these external materials like external hardware. And the beauty of the unibody design, then again will be common on all the META family, is that we managed to develop a technology that does not require any sort of hardware to combine or to unify those two blades. And there's mainly three goals on that. First of it, of course, it's the weight. Every time I can remove screws and bolts or wrappings from my foot, I can make a lighter foot. And of course, we know also that the foot being on the distal end of the pendulum of the prosthesis, every single gram counts, matters. And the lighter my distal end is, the better for my patient. So we definitely improved on the weight. This foot that you see here on the screen, by the way, it's like the META core. It's just a simple foot with a titanium pyramid in the top of it. The weight is 480 grams, so less than 500 grams without the foot shell, with a 95% energy return. So that brings me to my second main reason or feature of the unibody design. Every carbon fiber foot is intended to absorb energy at heel strike, transfer energy at mid stance, and of course use the toe off to impulse, to bring this energy back for my next step for my patient. So guys, we don't have to be nuclear engineers to understand that when I can remove these foreign bodies, these screws and bolts from my blade, the energy transfer from heel strike all the way to toe off, it's absolutely improved. When we have those foreign bodies, those screws and bolts, we create that, what the patient sometimes refer to that dead spot. The patient feels nice at heel strike, nice absorption, and then when transferred to mid stance, everything goes fine. And when they try to reach toe off, they feel like there's an interruption on this energy transferring, which is exactly because of these foreign bodies. When I can have a foot without the screws or without the wrapping, I absolutely improve my performance from heel strike to toe off. And that's why such a short build height foot, this foot, for example, has 10.5 centimeters, less than 11 centimeters. And even then, it can have 95% of energy return exactly because of this unibody design. And the final part is, of course, strength. Every time I have a solid blade with no screws, no holes in the middle of it, it's supposed to be stronger as a solid blade when compared to another one that has two holes in the middle. So those are the three main, I would say, advantages, characteristics that every foot from the META family will present, because every foot is built on the same chassis, the same body. The only thing that changes is the ankle and its function, but the chassis, the construction of the body of the foot will be always the same. All of them being always waterproof and corrosion resistant. They are rated up to 165 kilos, and we follow the traditional sizing from 22 to 30 centimeters, always with the 10 millimeters heel height. So those characteristics are common to all the feet that we'll be talking today and as part of the META family. All of them also present a split heel and a sandal toe. We know how important it is for countries like Australia or like Brazil, those tropical countries where having a sandal toe is not an option, it's almost mandatory, and we can combine that without losing any function of the feet. On this video, guys, is where I want you to pay attention and you will understand this whole unibody concept. Do you see this gap happening here between the two blades? If this is heel strike, toe off, heel strike, toe off, the connection between the lower and the upper blade is absolutely dynamic. It's like what we call like a rocking chair. It moves freely, allowing this energy transfer to happen. And the only part that actually connects the two blades is two small carbon fiber rivets here at the forefront of the foot, but everything else moves freely between the two blades without any hardware. So this is the visual explanation of how the whole unibody concept works. Keep that in mind because this will be, again, important for all the feet on the family. If there's any questions, please just refer to the chat and I'll be happy to address those. Before we go into more details, if I could make a snapshot, this is how the whole META family looks like today. We have on the left here the META core, which are the most basic, the core feet from the family, is exactly what I just explained to you, is the META foot with a titanium pyramid in the top. No extra motion, is the most basic foot, but also with an amazing energy return. In the US, where we are tied to the famous L codes, those feet are all addressed to the K3 and K4 level. In international market like ours in Australia and New Zealand, we are allowed to use those feet for all the way from K2 all the way to K4. And then we have the META arc, which is the second foot on this chart. And I will explain to you guys a little bit how it works. Then we have the META shock and shock X. The shock and shock X, the difference that shock makes only shock absorption, while shock X has shock and rotation, 40 degrees of rotation and 13 millimeters of vertical displacement. And at the end, on the right end, we have now the META flow, which is the newest addition to the family. So just to give you a kind of a wide spectrum of all the family, how it looks like from the most basic one to the most sophisticated one. So I just want to spend a few minutes with you guys explaining the META arc, because I think it's before the META flow arrived was the most innovative foot. And just for you to understand, this is the traditional setup of every workshop or of every clinic where everything looks safe, the patient is walking well, the physiotherapist or the prosthetist has his safe hand on his shoulder and everything looks good. So what do? We send them home. And as soon as we send them home, well, surprise, surprise, the world is not flat as our clinical environment is supposed to be. So that creates a challenge. And the reason that this foot was created was on a combined project with the NIH funding, where the challenge was to replicate our human ankle with our 23 degrees of eversion and 12 degrees of inversion, like our anatomical ankle always do. And if you think about most of the feet, prosthetic feet in the market, they have solid ankles, and the patient have to find a way to compensate for this lack of eversion and inversion that we have on our anatomical foot. That's why and how the META arc was born. So normally the good ideas are the simple ones. So here you can see inside the META arc ankle what is happening. It's not electronic, no microprocessor, not hydraulic, not pneumatic, just two very smart half-moon hinges that work at the same time as a polycentric system. And that gives me 6 millimeters of displacement, 12 millimeters in total, 6 millimeters in each direction, giving me this free inversion and eversion. So if I explode this ankle, you can see inside there's absolutely nothing electronic, nothing hydraulic. It's just a smart mechanical design that allows us to do what you are about to see in the next slide. So here you can see the META arc in action. And of course, intentionally, I chose a very stiff ramp so you could see all the range of inversion and eversion that the foot can provide on both directions. So now I want you to think about your own patients and how they would normally address this sort of challenges of ramps if they would be walking on a solid ankle foot. Most likely, the socket and the residual limb at the knee level will have to suffer to compensate, if not at the hip level, if not the whole trunk of the patient or the whole body. Or even worse, the patient probably will give up and just go around the obstacle and choose a different path to achieve his goal. But you can see how free and what range of motion this ankle offers to the patients. So on this next video, I want you guys to focus initially on the first time only at the ankle. Please just pay attention at the ankle, nothing else, just at the ankle. And look how much absorption and accommodation the ankle does when the patient hits the floor. Now on the second time, forget about the ankle and only pay attention at the knee and the distal end, the proximal end of the socket. Let's see it again. And I want you to see that the job that the ankle is doing with all this absorption is actually preventing the socket and the knee and the residual limb to suffer that impact. And that's exactly what happens at our anatomical ankle as the first joint working on that goal. It really brings comfort and confidence to our patients on their normal daily walking. If you look on the left-hand side here, you'll see a patient walking on an angle where one foot is flat and the other one is in a stiff angle. And it would be almost impossible for an amputee to walk on a straight line if it wouldn't be for this META arc ankle that adjusts to whatever degree it's requested. On the right-hand side, you have one of the most challenging scenarios, which is graveling, where the patient normally would walk looking down because he cannot anticipate what's the size of the next rock or stone that he's about to step in. When these patients are walking on META arc, they can absolutely forget it because the ankle will automatically adjust to the inversion or eversion requested, being a small amount of angle or degrees or a large one. And here you can see from the front, again, it doesn't have to be a huge adjustment. It could be a small, like 1, 2, 3 degrees, but it will in every single step adjust. And when the patient goes back to swing, it goes back to neutral, and whatever the next step requests, the ankle will adapt. No maintenance, absolutely free, and the ankle will come with the strength according to the foot category that you will be choosing. So you guys, as prosthetists, don't have to choose or be concerned about anything related to the ankle. And it remains being waterproof and resistant. It's an open chamber that can be easily rinsed and washed after exposed to the ocean, for example. So this is just a quick recap on the META arc. I want to pause here just for 1 minute because I always make a little self-critique here. This is a typical chart that we all use to choose the category from our carbon fiber feet, and that's almost the same across the industry. And again, being on this business for so long, and as a prosthetist myself, I have a strong issue against the chart, and I think we as an industry, we made a mistake. When we create these categories that we call the impact levels, and we name them as being low, mid, and high, we kind of misled the market to start choosing more mid and highs, while the majority of our patients should be on the lows and mediums. And that's because of a cultural experience connected to the words low and high. Generally, low is related to something not so good, and high is always something good. And I always tell this story about this very active patient of mine. He wakes up every day in the morning at 4 in the morning. He goes to ride his bicycle with his team from 5 to 7. So 2 hours really working hard on his bicycle. Comes back home, and at 8 o'clock, he's already at work, working for the next 4 hours behind his desk. And when lunchtime comes at noon, while everybody goes to have their food, he goes for the second training of his day. He goes for 1 hour of swimming, and then he comes back to work for the whole afternoon and goes back home. So when this patient came back to me for a new prosthesis and I have to choose his new foot, I did a mistake to mention, well, I'm ordering this low category foot for you. And he was always almost personally offended. Like, what do you mean low? Look all what I do. Am I not good enough? I'm not qualified to receive a high foot? And then I realized, and I had to explain that during his bicycle riding, the impact on his foot is almost zero, very low. Then the next hours at work, behind his desk, sitting on a chair, is again very low. And when he goes swimming, it's actually even less than low because he removes his leg for swimming. So technically speaking, the impact level of his activities on his prosthesis is low. But because of the wording, he would be offended with a low. So on the META flow that I will be covering today, you will see that for the first time, WillowWood is changing and kind of fixing this problem. And we are combining the low and mid categories together, and we are changing the wording, and now we are calling that category standard. So now we have two categories for the META flow, which is standard and high. And we hope that doing that over time, we will help the industry flow to the right categories and right choices, which 80% should be on the standard category and not on the mid-high. So with that being said, I think we can move now for the presentation of the META flow itself, which is what you see here on the screen. So on the next few minutes, I will explain how this polycentric ankle works. And if you have in mind that the META arc was doing all that work on inversion and eversion, the META flow was born to give the dorsi and plantar flexion, active dorsi and plantar flexion to our patients. So here you have the combination of all the aspects of the foot. It's again a unibody platform design with a polycentric ankle that provides 14 degrees of total range of motion, 9 degrees of dorsiflexion, 9 degrees of plantar flexion, and 5 degrees of active dorsiflexion. And this is all controlled by a carbon composite spring that we can control the stiffness of the spring and fine-tune according to our patient gait, mimicking or copying exactly what traditional hydraulic ankles do, but with the benefits of not being hydraulic. So here you can see, again, from the front and from the back. In the top of it, we have here on the screws on number 4 and number 5, we as prosthetists, we have the choice to make this fine-tune adjustment. We provide the key, the wrench to make this adjustment. And on this presentation, I'll explain how simple it is to make this fine-tuning. And of course, we continue to present always the sandal toe system to amplify the usage of the whole product. So on this video, we made a transparent 3D prototype so everybody can see through the ankle and understand exactly the polycentric system. Here you have the two hinges that makes this ankle polycentric. Here you can see the carbon C-shape spring that will control the stiffness of my dorsiflexion and plantar flexion. But you also be able to see on this video how the adjustment, the fine-tuning of this C-spring shape actually make this bar move forward or backward, making the stiffness of this bar change. So here you can see the polycentric ankle moving, doing its plantar flexion. And now with my wrench, I can look for that screw in the front and in the back. And just by losing one and tightening the other on the same amount, I will end up moving this bar. So please pay attention at this bar here where my hand here is, my arrow is, and you can see it moving forward. And by doing that, I am creating a different behavior on the spring. And again, the prosthetist will have this control to make this plantar and dorsiflexion more stiffer or softer. This is actually how the whole foot works. Let me try to go for the next slide. So here we have more the specifics of this foot. And you can see, again, the sizing and the weight. It is, again, a very, I would say, low build height for the whole foot. The weight of the foot without foot shelf is around 860 grams. It's still lighter than any other existing hydraulic foot. And one thing that's interesting to mention, guys, in the US, there is a specific reimbursement code for hydraulic ankles. And what our engineers at our R&D department did was to read carefully what are the wording, what does the description says on the L code related to the hydraulic foot. And surprise, surprise, what they found out is that at not a single time the word hydraulic is present. All what it says is active dorsi and plantar flexion. And that's how they have this eureka moment when they say, if I can make an ankle that behaves as an hydraulic ankle, giving me active dorsi and plantar flexion, but without being hydraulic, without the maintenance that every hydraulic system requires, and without the extra weight that an hydraulic system adds, and especially without the dampening effect that every hydraulic ankle has when the patient is trying to move forward, this will be an amazing new feature. And that's what actually happened. And I had to apologize to my international markets. When we launched the MetaFlow in the US, it was absolutely so sold out for a couple months in advance that I had to hold the launching on international markets just to be able to allow us to keep up with the manufacturing and delivery of all the pre-orders of the MetaFlow in the US market. Now everything is solved, production is at full, and we can address markets like the Australian and the New Zealand market with this new addition. Again, an ankle that behaves as a hydraulic ankle without being hydraulic. Continue to be waterproof and water resistant, the same weight limit. And here, guys, you can see for the first time this new chart that I mentioned to you. We combined the low and the mid categories to the new one called standard. So we have standard and we have high category for all those different sizes. I think this is the future, and I wouldn't be surprised if over time we manage to migrate all our other feet from the Meta family to the same system. Personally, I think that would be a right move, and I wouldn't be surprised if the whole industry will end up following us in the future. So here again, you have the Meta Core, just a unibody foot with the titanium pyramid in the top of it, with the option of carbon fiber or fiberglass. You have the Meta Arc with the in version and E version that I just explained to you. Then you have the Shock and Shock X that will provide vertical shocking and rotational torsion absorption, again with an option of carbon fiber and fiberglass, and the MetaFlow, which is the newest addition to the family. Just to show how the MetaFlow behaves, so here you can see all the things that we just explained in action, a patient walking on different terrains, and I want to focus specifically in one thing. So when we're going uphill, the foot always goes automatically by default to 5 degrees of dorsiflexion. This is the cherry in the top of the ice cream. So heel strike gives 9 degrees of plantar flexion, but the default is always on 5 degrees of dorsiflexion. Every time my patient goes to swing phase, the foot automatically gives me 5 degrees of dorsiflexion. And this is so important in terms of efficiency, but also in safety, because this gives me the clearance the patient needs to go to the next step. Especially, even more, if he's a transfemoral patient and he's using a single axis knee. So this 5 degrees of dorsiflexion always by default really has an important role on the efficiency and the safety of this foot. This is also unique. So again, just as a summary, if we go bring it all together, usually the traditional hydraulic ankles, they steal up to 80% of the energy that the foot plate is trying to bring the patient forward because of its passive behavior. So it ends up competing. The hydraulic ankle competes against the foot. The foot wants to move forward. The hydraulic ankle wants to go flat, but stays there. And what we managed to create with this carbon spring, the C-shaped carbon spring, is creating this shock absorption, at the same time the dorsiflexion, the plantar flexion, but it continues to push the patient forward, not dampening, not stealing this 80% of energy. So we still have the 95% of energy return. That's patients that are sometimes on this hydraulic ankles, they complain about this non-very functional or active ankle, and the MetaFlow comes really to solve that. And we do that by offering this 14 degrees of range of motion, 9 degrees of plantar flexion, 5 degrees of dorsiflexion by default. And we just described how important it is to reduce the risk of falls from all our users. And again, this is the first time that I am eager enough to use this word. There is absolutely no leaks guaranteed. It sounds like a joke, but I just want to make a really strong sentence here. It's not hydraulic, and by not being hydraulic, there's nothing to leak. There's no maintenance related to this ankle, and that's why it became so much popular in the US and now all over the world. Actually, it became a surprise to us. It started becoming one of the feet of first choices, not only to compete against hydraulic ankles, but the first feet of choice in general, just because of its overall function and cost benefits. So keep that in mind, okay? I mentioned to you about the adjustments and the fine tuning. This foot, guys, this foot comes with 5 degrees of dorsiflexion. And in order to make your bench alignment, we do provide a 5 degrees wedge foam exactly to offset the 5 degrees of dorsiflexion that the foot comes. So first thing you do to do your bench alignment is put the shoe on the foot and put the foot in top of this foam wedge that we provide inside the box. And by doing that, you are ready to perform your regular traditional bench alignment. Again, same thing. The weight line should follow in the transition between the posterior and middle third. From the back of the foot, it should always fall, splitting the foot in half. But remember, this is just bench alignment. As soon as you go to your dynamic alignment, I would always trust your eyes and your experience. Please use that, and you can always overrule your initial bench alignment. I am a true believer on dynamic, on real life, over IFUs or any static instructions that somebody can give to you from behind his desk overseas. Again, here you can see all the parts of the feet, of the foot. We already covered that. This is the wrench that we provide with every single foot. So with this long wrench, you can actually reach the 2 screws in the front and in the back in case if you want to make any adjustment, soft turning adjustment towards this C-shape spring. And remember, when you loosen one and you tie the other one, you are changing the position of this bar, and this is what will affect and change the stiffness of this ankle. I'll show you in a minute in a video. You can see with image how this happen on real life. Altogether, we offer 5 full revolutions, 5 full turns from the wrench, from the key, to do the adjustment. We provide the foot to you from the factory at the middle of the range. So that means that you have 2.5 revolutions to play in each direction. Oh, but what if I forgot how many turns I already give? Well, you can just go all the way to one of the ends. And by doing that, if you return 2.5 revolutions, you are back to the mid-range, which is the factory settings that we sent to you. Normally, 1/4 to 1/2 of a turn is enough for the patient already to feel the increment on the stiffness of his ankle. So I would recommend you guys to work on the same direction, always no more than 1/2 of a turn at the time. If I want to speed up plantar flexion, I want to make it softer, I will release the anterior screw. I will tighten the posterior screw, and remember always to tighten back the initial screw so the system is tightened off. There is no vibration involved. You please don't put any sort of Loctite and anything not needed, but just remember to bring your initial screw always back until it feels tight, until the wrench starts twisting, and that's enough. We don't need like a special torquimeter. It's a very simple mechanism to hold in place. If I want to slow down plantar flexion, I want to make it stiffer, it's the opposite. I will loosen up the posterior screw and I will tighten the anterior one, and then I will finish the process by tightening back again the posterior. As I said, I have a video showing that to you, and this will be more visual effect. So this is basically what you have to know regarding the adjustment, the fine tuning on the adjustment. So please, let's enjoy this video now here, where you can see all the adjustments that I mentioned. This is everything that we provide with every box. You can see here the bench alignment wedge, the foam, the adjustment tool, the spectra sock, and the guide. Just again, visually seeing how the alignment is made. Remember, put the shoe on the foot and then bring it to your 5 degrees wedge. By doing that, you're neutralizing the 5 degrees of dorsiflexion that the foot comes with. And now you're going to place your weight line exactly on the transition between the posterior third and the medial third of the foot. The foot shelf itself comes with a little dot as a reference to help you identify that position. This is just for bench alignment. Remember, as soon as you go for dynamic alignment, follow your eyes, follow your knowledge and experience. We'll trust your skills better than any static instructions we can provide you with. Again, when we provide this foot to you, it comes with a mid settings of the adjustment wrench. So always in the middle, and you have 2.5 revolutions to play on both ends. These screws will not fall off. If you try to unscrew it more than those 5 turns, it will not fall off intentionally. And all what we ask you guys is not to use any sort of Loctite. Just tighten those 2 screws are enough. So here you can see visually that I am loosening up the anterior screw. You can see I'm creating space here. And now when I push the posterior screw, I am moving this full bar forward until it reaches its end. And I go back to the posterior just to tighten it back in. And now I have this new adjustment. I just made this foot a little bit softer on its plantar flexion. If I want to increase the stiffness to make it a little bit stiffer, I will do the other way around. I will unscrew the posterior screw, creating space. Then I will come from the front and I will push the anterior screw backwards until it reaches the stop. And to finalize this whole process, I will tighten back on again the posterior until I feel it's tight and the patient is good to go. Again, no more than half of a turn at the time for the patient to tell us. And I want to show with you guys 3 different gaits. When it's too loose, it's too soft, you can see that the foot is coming flat too fast, too quick. In this case, I would like to stiffen this foot a little bit, the plantar flexion. The other gait is when it's too stiff. It's almost, the knee almost jackknives forward because it's too stiff, and I want to make it a little bit looser. And that's how we just did, by losing the anterior. And in a proper gait, I can see a good balance between the heel strike, mid stance, and toe off, and I don't have to do any adjustment. So I think we as prosthetists, we like to have the feeling that we can control. So even knowing that most of the feet will be performing very well with the adjustments that we provide from the factory, you always have the room to fine tune and adjust according to your need. I want to finish this presentation just sharing with you guys one display, active display that we created in the US. And actually we had the opportunity to bring it to the AOPA Australia. I don't know if you had a chance to play with it, but if not, I want you to understand what we are doing here. So this is the MetaFlow display stand. Every practitioner, every person that will participate, we will stand up here, and intentionally we have 2 feet fixed in this desk, in this table. One here on this pylon is our MetaFlow, and the other one, where the gentleman has his hand, is actually one of the traditional hydraulic feet. We covered it with a black box intentionally. We don't want to pick on any specific brand or unit, but we just want to provide a personal experience where the person can really feel the difference between the performance and behavior between the traditional hydraulic foot and our MetaFlow. So and this is a very amateur video made by one of my colleagues. what I want you to pay attention on the first 5 seconds is when this gentleman is playing with the traditional hydraulic foot, he will push this pylon, this lever arm back. And you can see here in the front, we create a little target, and we're going to place like ping pong balls with Velcro on the top of it, and we will compare the difference in energy return. How far can these 2 different feet throw these balls using just the energy return of the system? So on the first 5 seconds on the video, please pay attention to that, because you will see this traditional ankle, hydraulic ankle foot going back, but absolutely giving no energy return whatsoever. It will stay stuck to that position instead of giving any return. You see, it pushed back and stayed there, while the MetaFlow pushes back and bring everything forward again. Look, we already spent like 15, 20 seconds, and the hydraulic ankle is still there in the original position, helping zero the patient to progress forward. So the patient has to use his own energy to overcome that, while with the MetaFlow, as soon as he leaves heel strike, boom, the foot propels him forward, so gives the 9 degrees of plantar flexion, go to 5 degrees of dorsi, but combines the energy return that the traditional hydraulic foot does not. That explains that. That's the visual explanation of how different in behavior they are, and why our MetaFlow has become so popular in the US after that. So now you understand better the whole Meta family, how it was born with those traditional carbon fiber feet, and then we have the addition of the fiberglass part of it, and now we introduce the MetaFlow completing the family. All of them built on that traditional, on the innovative unibody design that I just described. With that being said, this is just a repetition of the whole product line, from all the way from the MetaCore to the MetaFlow. And I just want to take the opportunity to really thank you guys for your time. I will stop sharing so we can interact. If there's any question or any comments, Bill, I will give it back to you guys.
Sure. Thank you, Jairo, for that great presentation on the background of the Meta family, and fun demonstration of the MetaFlow with the active dorsiflexion ankle spring. All the Meta feet, including the MetaFlow, do come with a 60-day trial period. So you have the ability to order those, trial those on your patients for that 60-day period. Have a stock holding option, so they're available immediately.
And just to add one thing, Bill, especially on the Meta Arc with the inversion and eversion, and the MetaFlow with the dorsal and plantar flexion, the 60 days trial period for me is even more important because of the uniqueness of those motions. If you consider a Meta Arc with a solid ankle, it's almost a plug and play foot. There's no much to think about. But think about a Meta Arc, and you have a patient that has been walking for 5 years on a solid ankle from whatever brand, doesn't matter. If you don't take your time to, when you fit him with a Meta Arc or even with a MetaFlow, to explain to him what he's about to experience, he may really feel weird, because suddenly I have these new motions that I didn't have in the past. So for Meta Arc and MetaFlow, my strong recommendation is, please, even being a senior experienced patient, put him on the parallel bars, explain to them what they are about to experience, and let them discover in the first 10 steps inside the bars this new range of motion. And as soon as they do that, then they are ready to get out of the parallel bars and really discover the world. Don't let them go without finding in a controlled environment how this new extra movement works. And that's why the 60-day trial days work for, to encourage you guys to try new concepts without the fears, oh, what if the patient doesn't like, or what if it doesn't work? Use it on your advantage. I usually say just use it, but don't abuse it. If you return 5 feet in a row on day 59, probably Bill or Anton will give you a call to see what's going on. But again, use it on your benefit, and we trust so much our feet that we offer that to the market.
Sure, thanks, Jairo. That's a great point, because those feet certainly do have a unique feel, and we need to just provide our patients with that heads up as to, hey, this is going to be quite different to to what you've had in the past. And there's just a question here from Nathan.
Yeah, Nathan, thank you, because this is the most common popular question. Are there any plans to incorporate the META-ARC module into the META flow in the future and combine the benefits from the AP and ML? Believe me, it's on our mind since day one. The biggest challenge, Nathan, here is that by doing that, it will become such a solid big ankle that the weight and the size of this creature will be so big that we didn't find a way to, I'll say, minimize and combine the two. But function-wise, this is the most logic way to think. It's the best of both worlds. If I could have a mechanical foot with absolutely no microprocessor, no hydraulic maintenance, that could give me all this inversion, eversion, and dorsiplantar flexion, this will be like the best foot. So we are on that, but it's not an easy task from the design point of view to make it doable. But thank you for the question. You are thinking the right direction, same as we do. I would love to hear feedback for the initial fittings on your first patients on those, and how do they react. If you can record with some videos, always the first reaction is always vivid, it's always impactful, and I will be looking forward for successful stories from you guys. Thank you, guys. Have a great day over there.